Hey, what's up, C peeps? My name is Divesh Thakker and welcome to our channel Learn Competitive Programming with CodeChef. Now, just a reminder to hit that subscribe button if you haven't already yet, and also don't forget to hit that bell icon to stay tuned with us, and let's get started. So today, first of all, we will look at the problem statement, and until finishing the problem statement, we would look at the complete solution to our problem, and finally, we will also look at the code. So let's have a look at the problem statement. Here, ADA has a square matrix which has been given to us as our input. So basically we have been given a matrix, and the matrix is of n rows and n columns, right? Because it is a square matrix. So we have been given n and we have been given the matrix. Now there is an interesting property. It is written in the second line that the matrix contains all integers between 1 and n square inclusive. Okay, so let's take an example to satisfy this. Here, this is a matrix, right? And if you see, the value of n over here is 4. And all the elements inside this matrix are starting from 1 up till n square, right? So this is an example which satisfies. So let's take this one as our example. Here, in the second paragraph, it has been told that ADA wants to sort the matrix in a row major order. Now, what is a row major order? Let's understand what is a row major order. Let me take this down. Okay, so we have been told that ADA wants to sort the matrix in a row major order, and then we have been given the definition of a row major order. Let's take the same example which we had taken before. To sort this matrix in a row major order, what I need to do is the sorted matrix would contain the value inside the cell to be calculated by this formula over here. Okay, so let's say that the value of I, let's have the value of j, and let's have the result which we get by doing these operations. So here if you see, this element is of row 1 and column 1, right? So this is the 4 columns and this is the 4 rows. This element is at row column 1 comma 1. So the value of I and j is 1. And if you plug in this, your result is 1. Which means that, okay, in my resulting matrix, the value at this particular position is 1, right? Moving forward, at this position with the first row and the second column, the value inside that cell, if you plug it into this, is 0 into n plus 2, which is 2. Similarly, for this, I have 1, 3, 0 into n plus 3 is 3, so this becomes 3. Similarly, this becomes 4. Now let's move on over here. Here, the value of I is 2 and the value of j is 1, right? So what will be the value in the sorted matrix when the value of I and j is 2, 1? If you plug into this formula, it is nothing but 2 minus 1, which is 1, into n, which is 4, plus 1, which is 5, right? So here you put in 5. Now, similarly, if you continue doing and filling this table, you will see that the resulting matrix, the sorted matrix, would be something like 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Right? So we had a matrix as an example. When you want to sort this matrix in a row major fashion, it would look something like this. Right? Now, similarly, this is a standard case, right? Say for example, the value of n will be 3. I'm just taking an example. So if it was 3, then we would have 1, 2, 3, 4, 5, 6, 7, 8, 9. Something like this. Okay? So this is what is when you call a row major matrix. So now we are sorting our given input matrix in a row major fashion. Okay, let's continue with the other problem statement now. Here, ADA wants to sort the matrix in a row major order. So I can imagine this as my target matrix. So I've been given a matrix, I've been given n, which is the number of rows and columns. Then I am inputting a matrix and I want to sort this matrix. Let's go on, let's read further. In one operation, ADA should choose an integer n and transpose a sub-matrix between rows 1 and n and columns 1 and n inclusive. Okay, so we need to calculate the transpose. Now let us look what a transpose is. Okay, so forget about the L. Okay, now first of all, what is a transpose? When I say transpose, you calculate the transpose matrix of a particular matrix. So I've changed the example to make it more simpler. Let's take this M as our matrix. Now, I want to calculate M transpose. So while filling this M transpose table, I would say that, okay, M transpose of I, j is by definition M of j, I. So what you need to do is you need to reverse this I and j. This I becomes j and this j would become I. Okay? Let me really this becomes I. So let us carry out these operations. Say for example, I want to fill empty in my transpose matrix 1, 1. So I'll say, okay, I want the transpose matrix 1, 1, and the value inside this cell would be reversing the I and j. So this would be m of 1, 1, because 1 and 1, if you reverse, it's the same. So here the value would be 1. Right? So I put 1 over here. Similarly, for another case, let's say I want the m transpose of this position, which is 1, 2. So m transpose of 1, 2 will be reversing it, would be 2, 1. And if you see, 2, 1 is 2, which is 2. So I will add 2 over here. Similarly, let's calculate for this one. M transpose of 1, 3 would be m of 3, 1, and m of third row first column is 7. Just the last one, let's calculate for this position. So I want this particular position, which is 3, 2 for my m transpose. And as you would guess, this would be 2, 3, and m of 2, 3 is 6. So this position will be 6. So if you keep on filling, these two numbers will get swapped. So here will come 4. 5 remains the same because it is the diagonal elements. Now if we have a diagonal element, then I and j are equal, right? So it does not matter if you swap them, the element remains the same. Similarly, at this position we have 8, 9 remains the same because it is at the diagonal, and 7 gets swapped with 3. So this is how we calculated the transpose of a matrix. Okay, so let's come back to our question. In our question, we have to perform operations, right? And in an operation, we need to choose an integer L, and we need to transpose this submatrix. Okay, let's look at it. Let's continue now. The initial state of the matrix is chosen in such a way that it is possible to sort it using a finite number of operations. So basically, we need to sort this input matrix. We need to find the smallest number of operations which are required to sort the matrix. Okay, so overview, we have a matrix, we need to sort it and by performing some number of operations, and we need to calculate the minimum number of operations that are required to sort this matrix. Let's complete it by having a look at our inputs now. So as I told you, we have n and the matrix, and for output I need to contain output one integer, which is the smallest number of operations required to sort our matrix. These are our constraints, and I think this is the same example which we have taken so far, right? So that is what we have been given in our problem statement. Now let's look at the final part. Let's look at the solution for our problem. Remember, I told you forget about the L. Now is the time we will look at this L. Okay, so now let's take the very same example which we have been taken from the beginning, and this is the same example. I have just rewritten it. If you remember what I told you that we need to convert this matrix or sort it to a target matrix or a row major order transform matrix, and this is how our target matrix should look in case of this input, right? So I've already written that for you as well. Now let's take this L. If you see, L starts from 0 up till the value inside it, right? So here, if you want to name these rows as 1, 2, 3, 4, 1, 2, 3, 4 rows and columns, you would see a pattern over here. For L equal to 1, the submatrix would be this. For L equal to 2, the submatrix would look something like this. Similarly, for L equal to 3, this is the submatrix. For L equal to 4, this is the submatrix. Why? Because L starts from 0 or the first row, whatever, and it goes up till the value of L, right? So this is the way we would choose our submatrices from our input. Right? Now for this particular submatrix which we have chosen, we need to perform the transpose operation. Okay, so this is what it has to be. If you see closely here, we need to start from the top left, which is at this point, right? Now just pay close attention to this diagram. If you check over here, it is impossible to swap any element of the same column by not swapping the element at the top. I compulsorily need to swap this element in order to swap the any element below it in the column. Now what do I mean? Say for example, I need to take the value of L as 3. We all know that this is the submatrix which we will be having for L equals to 3, right? Now take the value of, now say for example you say that I want to swap this element 7. So you would take the submatrix to be 3. But if you want to swap this element, the first row element for the same column will always get swapped no matter what. So that is a guarantee, right? Similarly, say for example you want to swap 10. with now 10 will be swapped with 7, but if you want to swap 10, you need to swap 9, right? That is how we have been given, if you see at this pattern. So basically, if you see, if you take only the first row elements, the matrix gets automatically sorted. So we are basically interested only in the first row elements. If you sort the first row elements, all the elements automatically get swapped, right? So that's why I have created a matrix. Now what an array, and this is a Boolean array, right? So it can hold only true or false. Now this array is of size n. Why? Because I am only interested in the first row of my matrix, right? Now answer me one more question. For any particular position in the matrix, there are only two possibilities, right? Either you have 13, or after performing a transpose you have 4. There is no other number which can come in this place, right? Similarly, say for example, if you have a diagonal element, then the value is 1, because you just have the only element we have at the diagonal. You cannot have any other element here. Infinite number of transposes will also get you the same answer, right? So for each particular non-diagonal element, there are just two possibilities, either this or the other one after the transpose, right? So if you see, this finite word is very important, because it guarantees that the matrix, the given input matrix, can successfully be transformed to the sorted matrix by some number of operations, right? Okay, so then let's move on to our Boolean now. First of all, we would initialize our Boolean array. Now how would we initialize? We would check whether the element present inside our input matrix is in place. And when I say in place, basically it should be at the position where we want it in the target matrix, right? So let's start. If you start, 1 is in the position, so we would put a true over here. Similarly, 2 is what we require, so we don't need to change it, so we don't need to perform any operations, so I write 2 over here. But 9 is not in place, so what I would do is I would write a false over here. Similarly, for 13 we would have a false. So this is how we have initialized our array. Now let us loop in through this bool array. This is our first row, okay? And as I told you, if you start transpose the first row in place, automatically the complete sub matrix would come in place, and we would get our target matrix. Let's see how it happens. We would start from the end. Why? Because if you start from the beginning, then you don't know whether how many elements are having false. And if you are swapping this element, all these elements would also get swapped, right? But if you are swapping this element, the element behind that won't get swapped. So basically, if you are sorting an element from the end, all the elements before it will also get swapped, right? That is the reason we would start from the end. So let's start with our loop. Here, if you see, we encounter a false, right? So whenever we see a false, which means that that particular position at our first row, that particular number is not at its correct place. So now we would perform an operation, right? We would carry out the transpose. What do you think? What would be the value of L in this case, right? We would choose the value of L to be 4, because we want to set this element to be at its correct place, right? So whenever we are taking the transpose, we have the value of L as 4. This will be the complete submatrix, here the complete matrix for which we would be taking the transpose of, right? So if you see, let's start from here. This 2 will get changed with 5. So I will change this 2 and 5 to 5 and 2. Similarly, 9 will be changed with 3. So we have 9 and 3 getting changed with 3 and 9. Similarly, I have 13 and 4 getting changed to 4 and 13. So this becomes 4 and 13. Similarly, 9 and 3 get, those have been done. So 10 and 7 will get changed to 7 and 10. So this will be 7, this will be 10. Similarly, if you see, 15 and 12 will get swapped to 12 and 15. And yes, this is how it would look. And 14 and 8 would also get swapped. So this 14 and 8 will become 8 and 14. Okay, so this is the complete swap when I say L equal to 4. And if you see, this false will become true. Let's take green for the true. Why? Because if you see now, 4 is at its correct place, right? But as I told you, all these would also get swapped. right? And when I am swapping, I just basically need to change the false to true and true to false. So this becomes true. Here I had a true by before, so this will turn out to be false, and this will remain true because this is the diagonal element. 1 is the diagonal element, so it doesn't matter here, right? Because here we have false because this 5 is not at its correct place, right? 2 was at its correct place, but we have done a transpose. We have performed an operation, so now 5 comes over here, and hence we have a false over here. Alright, looks good. Now let's move on. Here, let's take the value of our loop. Let's go on forward. This is true. Whenever I have the value true, it means that the element is already at its correct place, so I don't need to perform any operation, right? So we move on forward. Here we encounter another false. Now I would choose the value of L over here as 2 because all these which I have looped in are already at its correct place, right? So I don't need to worry about them. If you see, all these are at its correct place, 3, 4, 7, 8, all these. So now what I am choosing is this submatrix, right? Because I encountered a false. So L equal to 2 will give me this submatrix, and if you change it, you will have 5 and 2 being changed to 2 and 5. Okay, and you would change this false to be true. Again, the next one here, you won't change it because this is 1. This would remain the same, right? And finally, your loop will get completed, and this is what you have transformed your original input matrix to while completing your loop. And if you check, this is the exact same loop as you have as you wanted for your target matrix, right? So here, if you see, what you would be outputting is, let's say we have a count variable, and this count variable will store the number of operations we have performed. In this loop, we have performed 2 operations at L equal to 4 and 2. So basically the value of our count variable will be 2, and this is what you are going to output to get your AC. So now let's look at the code for this problem. Here I have taken T as my test cases, then I have taken N as our input, and this nums array is going to store my matrix. So my matrix is N square, so that is what this array would store. Now basically this for loop is just taking the value of the matrix inside our array. So up till here I am just taking the inputs. Now I am creating our boolean array which is of size n, right? This is our first row array. So this is our boolean array. So yes, when I am creating the array, all the values are false. But I would check that, hey, if nums of I is I plus 1, which basically means, say for example, at nums of 0, that is the first position, so the value should be 1, so I plus 1. So that is what I'm checking, that if the value is at the correct position, then you need to change the boolean value to be true, right? You need to initialize it with true. So I would change it to true, else it is already false, so no need to do that. So this is our initialization step. We would check if it is at the correct position, then the boolean value would be true. After initializing, this is my output variable, the count variable, and then we would have a reverse loop. I would start from n minus 1, which is the end, up till the start. This is a reverse loop, and what I would check is, hey, if the value of the boolean is true, we don't need to do anything, no issues, so we continue. But if it is false, then I would do count plus plus. But hey, that's not it, because we need to change all those elements which are behind that as well, right? So j, let's take it from on I, and then we would do a reverse loop up till the first element, and we would check that, hey, if the value of the j at the jth index is true, then set it to false. If not, then set it to true, right? So that's what we are going to check here, and then we would move forward to our next I, right? So this is our reverse loop to change all these elements, and finally we end at the first index here, and then we are simply going to print out our count variable, right? So let's go on to submit this code now, and let's see what we have over here. So that's our AC for this problem.